In this video, we will discuss Introduction to Orthographic Projection. In engineering drawing, commonly four methods of projections are used: orthographic projection, oblique projection, isometric projection, and perspective projection. First, let's look into orthographic projection for now. Orthographic projection means the representation of three-dimensional objects into two-dimensional views on the drawing sheet. We get these two-dimensional shapes using parallel projection technique. In parallel projection, we project rays or line of sight onto the object that produces two-dimensional shapes on the screen or projection plane placed behind the object. Parallel projection literally means line of sight or projection lines are parallel to each other. These projection lines are projected perpendicular to the plane. So, if the projection lines are parallel to each other and also perpendicular to the projection plane, it is called orthographic projection. By this projection, the true dimensions of the object will be preserved. Every three-dimensional object contains 6 sides: front side, top side, left side, right side, bottom side, and back side. So, 6 views are possible for a three-dimensional object. From these 6 views, at least 2 views are required to represent complete dimensions of the given 3D object, like length, width, height. Sometimes, it may require 3 views if it is a complex shape. 3 views are important among 6 views. We can represent any object using these 3 views. They are front view, top view, and side view. We take these 3 views because we cannot draw three-dimensional complex objects on paper. So, we convert it into two-dimensional shapes and draw them on paper. Generally, we follow a format to represent the 3 views of an object on a drawing sheet. We first draw a reference line, XY, on the drawing sheet. The front view of the object is drawn above the reference line. The top view is drawn below the reference line. And the side view is drawn beside the front view. If we project the left side view of the object, it will be projected right side of front view. So, we draw it right side to front view on the paper. If we consider the right side view, it will be projected left side of front view. So, we draw it left side to front view on the drawing paper. This kind of representation is called first angle projection. We will discuss it in the upcoming episodes. In this video, we have discussed about orthographic projection. We will discuss about the principles of orthographic projection. Before starting the topic, we should learn about the space system and their division. Now let us start with what is a quadrant. The space is divided into 4 parts, named as first quadrant, second quadrant, third quadrant, and fourth quadrant, respectively, following an anti-clockwise direction, as we showed in the figure. If we place the object in the first quadrant while considering the projections, or 3 views, it is called first angle projection. Similarly, we call second angle, third angle, and fourth angle projection if we place them accordingly. Europe and Asian countries adopted the first angle projection, while the United States and Australia are using third angle projection. No countries use the second and fourth angle of projection for their representations of objects into orthographic projections. Because second and fourth angle projections cannot give a clear representation of the dimensions and are almost impossible to perceive. We will come to know why it happens as we progress. The divisions of the space are separated by two planes, commonly known as vertical plane, or VP, and horizontal plane, or HP, bisecting each other. These are nothing but the four quadrants. The plane in front of the observer is known as a vertical plane. The plane which is horizontal and perpendicular to VP is called the horizontal plane. The planes HP and VP are called principal planes. The two planes bisecting line, or line of intersection of two planes, is nothing but reference line. The reference line is denoted with XY because the two planes are nothing but XY coordinates. Our goal is to represent the 3D object on paper using 2D projections. But there are three views we need to draw on paper. And the three views are perpendicular to each other. So, we need to somehow design a standard way to represent the three views on the drawing paper so that, by looking at them, anyone can tell the shape and dimensions of the object. For that, we draw a reference line, XY. The front view of the object is projected on the vertical plane. We directly draw it on drawing paper above the reference line. But the top view of the object is projected on the horizontal plane and it is perpendicular to the VP. So, we represent the top view of the object below the reference line. Now, you may get a doubt about side views. Where can we draw them? Well, we consider another plane, which is perpendicular to both HP and VP. This plane is called the profile plane. The side views of the object are projected on profile planes. The left side view is displayed on the right side profile plane, and the right side view is displayed on the left profile plane. The left side view should be drawn right side to the front view on drawing paper. The right side view should be drawn left side to the front view on drawing paper. So, this is how the views of projection in first angle projection looks. And this is how we represent them on drawing paper. In this video, we have discussed principles of orthographic projection.